Okay, welcome back to Dynamics ECS 429. So for today's class, today is already 16th December 2021. It's 11:09 a.m. and this is already week 9 of the class. Okay, week 9 part 2 tutorial lah for week 9 part 2 tutorial lah. So for today's class we are going to go into we're still in, so if you open your lesson plan, so basically we're still in plane motion of rigid body but for Newton's second law. So okay, all of you can see my screen. Okay, so we are in topic chapter 4 which is a plane motion of rigid body, Newton second law. Okay, you can see my screen, Okay. So for today's class, what we're gonna do, we're gonna focus. Hello guys, can you see my screen?
Yes.
Okay. Alright. Sebab kadang-kadang takut keluar pula tiba-tiba kan. Okay. So for today's class, we're gonna concentrate on equation of motions. Okay. But rotation about a fixed axis. Okay. Alright. So, okay. I'm going to draw a diagram, okay, to make you understand the concept and the fundamental. So let's say we have, a rigid body. It can be any shape lah. Okay, let's say this is our rigid. Let's say this is our rigid body. Okay. Okay. So let's consider a rigid body as you can see in this diagram, which is constrained to rotate in the vertical plane about a fixed axis, that is perpendicular and passing through point O. So let's say this is our point G, okay, and this is our point O. Okay. All right. So this is our point O here. Okay. All right. So the angular, so basically there will be forces acting on top of it. These are all external forces lah. Okay, we have lots of external forces acting on top of it. Okay, all of these external forces, let's say F1, okay, I just label it F2, F4, F5, F6. So all of these external forces is what is causing for the rigid body to have what you call what is omega, angular velocity, and what is causing it to have alpha, angular acceleration. Remember that? So this is angular velocity. Takutlah ada lagi yang terlupa ke. And this is angular acceleration. Okay, so these forces is what is causing the rigid body to have this angular velocity and angular acceleration. Is caused by these external forces. These are called external forces. External forces. Okay, all right. Because as you can see, this body has a center mass G that moves around a circular path. So what we can say is that the acceleration of this point is best described by the tangential and normal components. So what we're going to do is we're going to describe the acceleration using tangential and normal components. So the tangential and normal components is uh, okay, the one that I'm drawing here, what do you think is? Will this be AGN or AGT? Which one?
AGT.
AGN, AGT, because the normal force usually direct to the point center O, for example, can be, and it can be AGT, this one. Okay. All right. Okay, good. Okay, so and it must be act in the direction of alpha, AGT must be in the direction of the motion. Okay, all right, okay, all right. So that is the normal and the tangential components, and then you must understand that the normal components, which is A, G, N, the normal components is equal to what? R omega squared, R omega squared, and R ni is respect to G, so let's say this is your R lah, the radius lah, okay, and then AGT, what is the formula for AGT? Is alpha R, remember?
Yes.
Okay, jangan buat lupa pula, kan? Okay. Alright, so the next thing is what we're gonna do is we need to understand this by drawing the free body diagram, Okay, so now let's draw the free body diagram and the kinetic diagram. Okay. So the free body diagram will equal to the kinetic diagram. So because what is important is that you are able to draw these two diagrams lah. Okay. Okay, now, so let's say this is our G tadi. Okay, this is our point O tadi. G, and this is our point O tadi. So at G is where we're going to have the weight, betul tak? W lah. The G is where we're going to have the weight. And then all this external force, you kena consider lah. Okay, tak kisahlah. Depends on how the question is, And then, of course, dia ada moment lah. Okay. Alright. So you ada moments involved, moments. Okay, now M lah. Alright, so this is going to equal to the kinetic diagram lah. So the kinetic diagram is where you're going to have what? What? Remember? M? Yes. One is MAG and the other one is MAT. Sorry, MAGT. Okay, one is normal, one is and because you are the moment ni, you akan ada apa? I alpha. Okay, alright, this is the important thing lah. IG alpha. Okay, and then you punya R, jangan lupa you punya R dari mana ke mana. You punya R, it must be from here to here lah. Kan? You punya R lah. Inilah R ni jugalah. Okay, R you, Okay. Alright. Okay, so basically what you need to do is you can create the equation apa? You akan apply the equation of motion, and what is the equation of motion for this part is summation forces Fn equals to MAGN, and you know AGN is what? Apa? R omega squared tu kan? And summation of forces Ft equals to MAGT, which is MR alpha atau alpha R, tak kisahlah, same. And then lastly is summation forces, you take moment dekat G. So when you take moment at G equals to I G alpha. So this is the important thing lah. So what I want to highlight for today's class, what is important is this formula, this new formula here. Moment, when you take moment at point G, you must have I alpha. Okay, so these are the equation lah that you need to consider. Now, this one is if you take moment at point G. You can have a question where you need to take a moment at a different point lah. Let's say you need to take moment about point O, for example. So when you take moment about point O, formula dia sama. Fn sama dengan MAGN summing forces Ft sama dengan MAGT, but the different formula is for moment at G. So when you take moment at a different point, dia punya apa formula dia is different lah. You need to take moment at I-O alpha. So when you take at a different point I-O, what is the formula considered? Macam mana? So when you take a moment at a different point O, sorry, ni kena tukar lah, bukan mg lah. Dia kena take at moment O. Sebab you can take moment at many points. Boleh moment at point O, point A, point B, point C, depends on the question kan. So if you take moment at point O, you need to the formula for take moment at point O is different lah. You need to use this formula lah. Sekejap apa the take moment at different point. I-O ni adalah equals to IG plus MD squared. Do you remember that? This one kita learn in last class. Okay, alright. Okay, so this is the thing that you need to remember. Okay, so can we continue and do one question? So basically what you need to understand is when you consider plane motion of a rigid body using Newton's second law, the key pointing is what you want to do is this is a kinetic problem where you want to solve the rotation of a body at a fixed axis. So either the axis fixed at point G or at a different point lah. And if you can see what we did here is we established the free body diagram and the kinetic diagram lah. So when we establish the free body diagram, you ada weight, you ada moment, and in the kinetic diagram you you kena recall the acceleration lah. One is normal, one is a tangential, and then you kena consider the moment of inertia lah, I alpha lah. And here kita kena describe what is the equation of motion kita nak use lah. If you're taking moment at point G, that is the formula. Apa? If you take at a different point, dia punya formula different lah. Okay. So if you're okay with this understanding and this concept, can we start and do one question? Boleh?
Yes.
So that you will understand it, okay? We do one question for today's class. So hopefully you habis awal, kita can finish early lah. Okay, and then you can study for your test lah. Okay, please copy this question and understand. Okay, tell me when you finish copying the question.
Dah.
Nah, okay, laju je. Okay. So, the unbalanced 25 kilogram flywheel shown has a radius of gyration K, 0.18 meter, about an axis passing through its mass center G. If it is released from rest, determine the horizontal and vertical components of reaction at the pin O. Okay, so dia nak reaction So number one, what we do is, what is our first step? So this problem is involves rotation of a body, obviously, about the fixed axis. So the procedure yang kita kena solve is, kita kena, if you notice for this question, what we need to do is, kita kena establish dia punya N and T coordinate system lah first. Okay, so number one, let's draw the free body diagram lah. So let's draw, so number one, the kinetic diagram will equal, free body diagram will equal to the kinetic diagram lah. Okay. So this is point O. So because this is a reaction, this is the support ni, nampak tak ni? Warna apa Yang orange ni. Orange ni support. So support akan ada apa? Reaction, betul tak? Kelas? Support akan ada reaction. So let's say you have the reaction. Sebab dia adalah point O, kita boleh namakan dia O apa? OT, ni boleh jadi OT, ni boleh jadi ON lah, reaction lah. Okay. Alright, so OT ni ON. Alright, for example. And then apa lagi? Sebab dia ada G kat sini, dia akan ada apa? Ni apa? Weight. W, weight. Okay, alright. Okay, alright. So, and then this is the free body diagram. Okay, and then it will equal to the kinetic diagram. So, ni adalah point O ni, ini adalah point G. So, dekat G ni akan ada apa? Akan ada M apa? M apa? M alpha R lah. Okay, alright. And then ni akan ada M R omega lah, squared. Okay, alright. And then one more yang dia akan ada, because ada rotation, dia ada apa? I G alpha, kan? Dia ada rotation kan? Benda ni rotation, dia ada rotation kan? Okay, alright. So this is what you call the kinetic diagram. Okay, now, so that is good. So you dah establish the N and T coordinate system, and then you have identified the sense of direction, which is the normal and the tangential acceleration punya direction. Okay, alright, good. And then you dah draw, okay, and then you also have determined the moment of inertia, IG. You have drawn that. So now what we can do is we can identify apa the unknowns and apply the equation of motion lah. So let's write down the equation of motion involved, which is Fn equals to ma. Okay, what is it? Terus ma g n, which is also equals to mr omega squared. And then kita ada Ft, okay. Alright, so for this question, kita can assume, okay, this is just an assumption, Kita can assume anyway, MAGT equals to apa? MR alpha. And then one more equation, which is the important equation yang I need you to understand in today's class, is equation of moment G. So equation of moment G, let's say clockwise pula positive. Okay, kita kena try different ways. It will be I, G, alpha. Okay. So now let's now write down the equation that is involved here. So if we look here, if we write down the equation involved, so what do you have in the direction of Fn? In the free body diagram, Fn ada apa? Kelas.
ON.
Yes, kita ada ON. ON tu akan jadi positif ke negatif?
Negative.
Okay, negatif ON equals to apa? Mass dia berapa? 20? Betul? Betul lah. 25. Okay, kali R 0.15. Okay, how about omega? What is the omega here? Cuba read the question carefully. So what is the omega?
0.
Yes. So for this question, our omega is 0. Why? Because it's released from rest. So last ON kita sama dengan 0. So dah dapat lah first answer. ON kita is 0. Okay, next FT pula. So what do we have in the T direction? Kita ada OT. OT tu positif ke negatif?
Negative.
Okay, negatif OT lagi plus weight, betul tak? Weight dia ialah 25 multiplied by 9.81. This is 25 multiplied by 9.81. Okay, ada apa lagi? Itu saja. Equals to 25 multiplied by alpha. Alpha kita tak tahu. R adalah 0.15. Anything else? Tak ada dah. Itu je lah kan? Okay. So dekat sini kalau you perasan ada dua unknowns Ada dua unknown, satu OT, satu alpha. That's why kita ada third equation. So now let's look at the third equation. So our third equation adalah apa? Kita kena take moment kan? So all this reaction force kita kena take moment dekat point G. So kalau OT kita take moment dia clockwise direction, so OT positif ke negatif? Plus? Multiply by the distance. The distance mesti perpendicular. What is this distance?
0.15.
Okay. Apa lagi? Okay, ON tak boleh because it is in the same point as point G kan. So tak ada direction. Tapi kita ada weight. Weight pula negatif kan?
Yes.
Tapi sekarang ni kita tak boleh nak consider weight. Why? Because dia dekat point G. Dia no distance class. So we don't need to consider the weight. So untuk take moment kat point G, ON dengan weight tak consider sebab they have no apa?
Jarak.
There's no distance, okay? So it's only OT, okay? So there's no distance for weight also. Okay, jangan silap buat macam tu Which it must equals to I. IG kita kena cari kali dengan alpha. Okay, what is I? I ialah moment of inertia. Now, remember since this is a bentuk disc circular, there are two formula I's yang I give you last Monday. What is it? 1/2 mr squared. Lagi satu? mk squared. Ingat tak?
Yes.
Okay,
Yes.
now, so which formula you want to use?
MQ square.
Why?
Segregation.
Yes, good. Jangan buat silap because it gives you radius of gyration. So you need to use the MK squared. Okay. Jangan buat silap Sometimes you can get full mark tapi sebab you silap. Okay. So you punya M adalah 25. You punya K untuk soalan ni adalah 0.8 squared. So if you calculate you punya I, what do you get? I want everyone to tekan calculator to get, and the unit is what? Kilogram meter square, bukan meter cube So OT kali dengan 0.15 equals to I 0.18 alpha. Okay, so now you have these two equation. Okay, you have these two equation ni dengan ni.
I itu 0.81.
Betul lah, silap. Thank you. Balik. Okay. 0.18, okay, 0.81 kali alpha. So you ada dua equation ni, tolong dapatkan apa tu ON dan apa tu OT. You're calculating guys? Ke you studying still design? Okay, what is the answer guys?
OT 26.8 ke bukan Jangan salah.
26.8 tu apa? Sorry.
OT.
ON dah kosong kan tadi? OT
O
salah.
UN kosong. Oh betul lah.
Alpha. Sorry, alpha apa? OT apa?
Oh, okay.
OT 14.4.
So OT sama dengan 14.4.7. Unit dia apa? Unit.
Oh ni apa ni?
Ni kan reaction. Apa unit reaction? Force?
Newton.
Newton. Okay. Kita boleh je buat FN force, reaction force force FA kan, ataupun A. Dia just a label yang kali ni label dia OT. Okay, so jangan terlalu confuse. Okay, alright. And then apa value alpha? Alpha ni adalah
26.8.
26. 26 apa?
8.8.
Unit dia apa?
Rad per second square.
Okay, good. Make sure you buat angular acceleration. Okay, good. Alright, now, so for the same question right now, as you can see, you take moment dekat mana? Kat point G. Now, boleh tak you take moment dekat point O? Boleh. And you can get the same answer. Tapi as I mentioned, kalau you take moment kat point O, apa additional formula yang you kena consider? MD squared. Tapi sekali ni, because dia circular ni, dia tak ada D lah, dia R. Okay, MR squared. Okay, alright. Ni D ni kalau yang rod lah yang kita buat last week tu kan. Okay, so it means you can do the same question, but you can take moment at point O and you get the same answer. Okay, good. Alright, so that's why you need to try different types, okay, of questions so that you can understand better lah. Okay, so good job. So for today's class, what we do, I'm going to recap. Today, we're doing plane motion of rigid body using Newton's second law. So for today's class, I'm focusing on how to consider motion about a fixed axis. So for this question, we have identified this is a kinetic problem, and to solve ataupun which involves things that involves rotation about a body at a fixed axis, what we can do is we can use this following procedure lah. And this procedure involves establishing, okay, number one, what do we establish? If you notice, number one, what we did is we established the N and T coordinate system lah. Okay, we want to use this system, N and T coordinate system, and then we identify we specify the direction of AG, and then we specify AG, direction of AGN and AGT, and then we draw the free body diagram. Is that right? Okay, we will draw the free body diagram and then kinetic diagram as well together. And then we also determine moment of inertia. Those are the things. Or if it takes moment of inertia at point G, senang je lah. Kalau take moment of inertia at point O, dia formula dia berlainan lah. Ada additional md square atau mr square lah. And then after that you apply the equation of motion. So ni equation yang kita nak pakai lah. And then basically kita apply the equation of motion. And then kita identify what are the unknowns yang kita nak solve. And then lastly kita nak solve the problem lah. So that is what we do today lah. But at the same time, for this type of question, I nak you be alert and aware that there can be questions that we still use the basic kinematic equation. And the question with constant acceleration. You remember that? Banyak kali dah pesan. So basically in we may still sometimes need to use basic kinematic equation and constant acceleration to solve together these questions. And you remember kan, omega equals to d theta over dt, apa? Alpha equals to d omega over dt, and then alpha d theta equals to omega d theta. And then constant acceleration, you ingat lah ada 3 kan? All the omega equals to omega naught plus alpha t. Okay, sikit je. Alpha theta, theta naught sama dengan omega naught t plus 1 over 2 alpha t squared. And last kali ialah omega square equals to omega naught square plus 2 alpha theta equals theta naught. Okay, so just need you to be alert. In this type of questions, maybe sometimes ada question yang not as straightforward as this, but you maybe need to use gabungan lah, basic kinematic and constant acceleration. But the important thing is you know that if you get this kind of questions, you need to establish the n and t coordinate system, specify the normal and tangential component of acceleration, draw the free body diagram, kinetic diagram, identify the moment of inertia, IG, use equation of motion, identify what are the unknowns, and you can solve the problem. If you understand this concept, I believe if you ada soalan yang susah pun, macam mana pun, you can still survive and still can solve the problem. Class. Okay, all right. Okay. Is there anything else you would like to ask? So I can stop this video recording so that I can download. Okay.